So we're solving essentially a determinant equation, and it says the value of this determinant is equal to -2. So you're going to take the determinant of the left-hand side. Remember, this is down, which is x squared, and this is up, which is 3. So it's down minus up is equal to -2. So now that's the value of that determinant. It's x cubed minus 3. Well, you want the value of that determinant to be -2. And so if I want to, I can do one of two ways. I can bring everything to the same side, 0 on the other. This is where you guys have to be careful because you forget. If I bring the -3 over as a +3, this is x squared equals 1. But then when I take the square root of both sides to solve, don't forget the plus or minus. So x is plus or minus 1. The error that you guys make is you forget the plus or minus. And that's made all the way through the engineering calculus. And eventually, you get broken of that habit. It breaks you. Because you make the mistake too many times, and at that point, you then vow, I'm never going to make that mistake again. Now, on this guy, I could do using minors, and as a matter of fact, on the review, I picked a very nice one in the in-class review, because we have to make it a little quicker. And that was this guy, right? And I notice if I go across using minors, the easiest way to do this one is minors, because if I go across here, the only thing that contributes is the x. So I only have to calculate at one minor. That's much quicker. So that's how I did that. But most of the time, which is what we're going to do, since this is a 3 by 3, I can use the quick method and not minors to do the problem. You know, it's the down minus up. That's where you repeat the two columns on the outside, and then the down minus up is much quicker than trying to do it with minors. And but either way would work. And so I take a look at this guy, and I'm thinking I could probably do minors because with a 0 there, I'm only going to have two numbers coming out. Or I could, in this instance, I could write and do the crisscross method. So I'm going to go ahead and do the crisscross method. And so all I'm going to do is do the value of the determinant. And then remember what we do is we rewrite the first two columns to the outside. And then it becomes down minus up. I start in the left-hand corner and go down. And then the next one is down. The next one is down. So this would be 3 times x times -3. That's -9x.
Jackie, you have a -3 where it should be -2.
Ooh, that would be bad.
And the one next to it, the 3, 1, 2, is that supposed to be 3, 1, 0?
Well, you're on the other one in pink.
Yeah, you put 2.
Okay.
Picky people. 3 times x times -2, -6x. Now it's down. It's videoed for the life of this. So 2 times 5 times 0 is 0. So that's going to be a plus. 4 times 1 times 1 is 4. That's a plus. So down I get -6x plus 0 plus 4. I'm going to subtract. I'm going to subtract what I get going up. So I start in the far left-hand corner here, and I get a 0, I get a 15, and I get a -4. So this is going to be 0 plus 15 minus 4. So I get a negative 6x plus 4 minus, no x's, that's nice, minus 11. And by the way, this is now equal to 0. Because remember, the original thing was equal to 0. So this whole thing is equal to 0 in the end. So that minus 6x minus 7 equals 0. Minus 6x equals 7, or x equals 7 over negative 6. And that's something that in the engineering world, it's not unusual that you want to have a determinant be equal to 0 for particular reasons. Oops.